Hello there. Welcome to another problem session. So today we are going to do a couple of problems in the overall, problem set of the type which have 2 mirrors. So, for instance, you can have an object between, say, you have a mirror, another mirror, and an object over here. So there's 2 plane mirrors, or you can have instead of these plane mirrors, you can have a concave mirror. That will be this case, or you can have a convex mirror. So object is here, this is the object, and this case, or you can have a concave mirror and a convex mirror. So you can have this situation. So I'm going to actually just do this case and this case. Okay, so let's work one example in each case. All right. Okay, so here is an example of 2 plane mirrors, M1 and M2, and there is object. Just going to use a point object. You can have an object of any shape, but just point object will be enough. And it's the distance A from mirror M1, and this distance is D minus A from mirror M2. Okay, so where the image will be? So of course the light will be, we assume that the light will reflect from here and form an image here, and so on and so forth. So let's draw a line to look at the images. So, just from the reflection into this, there will be image here. So let's call it image from reflection in just one. And if you look on this side, there is that distance, this distance from there. This image just reflection into, and this will be D minus A distance away, and this will be A distance away from there. But this image now is going to serve an object for this mirror. And so as if this was the object distance, so this is like, this becomes object for 2 for M2, and so that distance away, that distance away, so this will be from this mirror, this distance is D plus A. So this is going to be D plus A, and this will be image 1 and then followed by 2. So this one has reflections from both mirrors. So this has reflections from both mirrors. You can draw rays, and you can actually see that. Say if you draw a ray like that and a ray like that, so if you took 2 rays like that, and this will seem to come from there, and this ray, and then reflect from there, so these 2 rays will meet over there. So it has reflection from this mirror, and then reflection followed by reflection from that mirror. So it has information about rays like that. Now this would serve an object for that. So this distance will be the object for this mirror, this image, And what's the distance? Is d plus d minus a, so this is 2d minus a, and it's going to be over here 2d minus a. So this will be image first in the reflection 2 and then reflection in 1. So these are you can see now this will serve as an object for this, and this will serve an object for that. So this image now serves as object for M1, and so there will be that distance, and that distance further there will be image first in 1, then 2, then in 1, and this will serve an object for M2. So you'll have this distance, and from this distance behind will be another image over here, and this is the image over here. This is the image first in 2, then in 1, then back in 2. So that's another image. So this image you can see is going to continue forever, and you can locate the distances by working out like that. Okay, so this is a two mirror problem, two parallel mirror problem. Let me say if the mirrors were, say, not parallel, say one was like this and the other was like this, then angle between them, say this is 60 degrees, and you have a object here, then what will the images? We'll do exactly the same thing, and then we'll find that these images, find all the images here, just working like that. Okay, let's do this problem first. We have two mirrors, plane mirrors, and this is 90 degrees, and there's an object here. Okay, so again, this will be the image in 1, and this will be image in 2, but then we need to extend this to see the image of this over here. So this will be image of 2. This becomes an object for M1, and so it will be image in 1 of this thing. And if you extend this guy, and this will be the same. So this is the image of 1 in 2. So there will be 1, 2, 3 images. So this one is this image has rays which reflect from both of them. It's like this one is just reflecting from this. This one is just reflecting from that. So if you look at, some rays will go like this, and it's gonna seem to come out of this image. So it's got these rays have information about both, reflection from both of these mirrors. Okay, so now suppose you do 60 degrees. If I don't have a placed at a symmetric point like this, then the drawing is a little bit complicated. You should try to do it. Maybe you can try to get a graph paper and try to do an object over here. Maybe this distance is x and this distance is y, and try to figure out for such a situation. I'm going to do just for A and A. So this will be image in 1, and this is image in 2, and then again, if this guy reflected over there will be image of 2 in 1, and this guy reflected over there, image of 1 in 2, and this guy can reflect over here, image 1, 2 in 1. But if I reflect this here, this is the same edge image of 2, 1 reflected in 2. So this and this are images just from the single mirrors, and this in this from both mirrors. But then there are rays which actually reflect and then come out, and one, like this one will be maybe goes here and goes here, and then so it has to come out of which mirror. So if I have one, so suppose I go, if I go like this and go like this, if I do sufficiently go this way, go this, and then to get here, and let's try to reflect in this direction, go this way, then it's going to come back in that same direction. So this ray will be a ray which reflects from 1, goes into 2, reflects back, and reflects back again in that direction. So this is one way to see there will be this image. So there are 1, 2, 3, 4, 5 images. Okay, let's do a more interesting problem where we have 2 concave mirrors now, and they're facing each other, and you place an object here, and the top one has a little hole. This kind of looks like a little hole, and you have like a ball with a little hole, and this side is silvered, and so you have some light source, diffuse light source, and some of the light will go in and reflect. The bottom part is like that, so it's going to reflect around here, and light will get out. So this is a structure, and inside there, so you have this ball, and maybe you have put an object down there, and these balls are radius of curvature are same. This is a nice toy actually. So in this toy, basically you have a light source here, and so when you look at it, you will see a floating object right there. It's kind of very interesting toy. When you look at it, you place a penny here, so you'll see a floating penny here. That's what the real image is. It's going to actually look like it's like floating up in the air. Okay, so and we want to see what the image will be. Of course, there will be infinite number of image. So the one I'm showing is first is that image, and so this I1 we're going to locate through just one single mirror, and then I2 its rays will come in and reflect off this mirror, and so this will be so for find I1, use I1 as object for mirror M2. Locate I12. Okay, and you will see the I12 is very close to there, and actually right at the hole, if this object is right touching the base here. All right, so how do we find I1 first? It's very easy. So we have this system. The hole doesn't make a difference, right? Because it's any part of the mirror you can take out and it still make the same image. So I'm here, and this is the vertex, and so this side is going to be positive for this mirror, and object distance is, this is the object distance P1, and this is this distance is r/2, which is same as focal 1. So because this is within the focal, it's going to be a virtual image. So 1/q1 is going to be yes, so it's going to be, image will be behind over there. 1/q1, 1/f1 minus 1/p1, and we're going to use numerical value just to be, you know, simple formulas. You can work out the just plain symbolic answers if you like. So this 1/10, suppress the units, 10 centimeters, and the p1 here with this going to be, if this is 10, then this 1, and this is 9, 1/9. So we can do 90 minus 10 is minus 1/90. So q1 equals minus 90 centimeters. It's going to be way out there. It's not to scale. I1 is very far away in this picture, because that's where it will be located. A negative means behind the mirror. Okay, so now we use that object. So it's from here to the image, it says 90 centimeters. That's where I1 is. So we have now this mirror to work, and this distance, now this is an object. So this will be my positive side, and this distance is P2 now. Up to here was 90, and this is 10 in centimeters. So P2 is 100, 90 plus 10 is 100 centimeters. F2 is the same, 10 centimeters. Then from there I find 1/q2 is 1/10 minus 1/100. So this is really a little bit less than, let's make it 100. So 10 minus 1 equals to 9/100. So q2 is 100/9 centimeters, which is like a little bit more than 10 centimeters. So you have a 9 and then 1 0 again. So it's just a little bit over here, and so it will be it's a plus, so it's going to form on the same side, and this is 10, so it's going to form over here. It's it will look like hanging out there in the midair. Hope this helps you. So I'm not going to do the other types of two mirror problems. If you want to practice, you can work with some friends or your teacher or something like that. There are really a lot of interesting problems that you can think of. You can, right here, you can say, what if this was not a convex mirror? Maybe a concave mirror, maybe convex mirror, maybe this was convex mirror, what will happen? You can just ask all those what if questions. All right. So if you like this kind of explanation, you can subscribe to this channel, and I'll try to post more solutions of interesting problems. Take care. Bye.